Hello friends. In the last video you have seen that a single pile can be embedded into the ground and its load carrying capacity can be found out. So in the cohesive ground, for a single pile, you have seen the ultimate load carrying capacity is given by this expression. The ultimate load carrying capacity of a single pile is given by alpha times CO into pi dl plus 9 times CO into pi by 4 d square. But a single pile is seldom used. The reason being that if you use single pile in the ground, the axial load is not going to meet with the CG of this pile. As a result, there will be eccentricity and there will be flexural forces. Flexural stresses will get generated into the pile. Therefore, piles are always used in groups. So that even if there is an eccentricity, the flexural forces will get distributed over the piles. Number of piles. So if the piles are used in a group, what should be its configuration? So configuration of the pile group is very, very important. The minimum number of piles in a group is going to be 3. So minimum number of pile in a group cannot be less than 3. So if you are using 3 piles, the configuration is going to be a triangular pattern. This is known as triangular pattern. If you are going to have a square pattern, say you are going to have configuration, pile configuration like this, there are 4 piles, 2 by 2 or 3 by 3 piles in a group, you can arrange it in a square pattern. Isn't it? If there, say, number of piles are, say, 6 number of piles, in a group, then you can arrange it something like this. This is called rectangular pattern. You can also use piles in circular pattern. You can use it in a circular pattern. Something like this. Or you can use pile like this also, in this pattern. This is called diamond pattern. So, pile groups, piles in group can be arranged in any one of the pattern. But the most preferred pattern is going to be either a square pattern or a rectangular pattern. Seldom you will be using circular pattern or diamond pattern. The reason being, circular pattern, there will be construction difficulties. And therefore, the most preferred pattern is going to be these two patterns. Then how to find out the ultimate load carrying capacity of this pile group if it is embedded in cohesive ground? So today we will see pile groups embedded in cohesive bed. Pile groups embedded in cohesive bed. So the ground is cohesive. We want to find out the ultimate load carrying capacity. The ultimate load carrying capacity of the pile group Q ultimate for the group G, QUG. So the ultimate load carrying capacity of the pile group is based on individual shear failure shear failure. What do you mean by individual shear failure? Say we have the pile groups arranged in a square pattern. So there is the pattern of the pile groups, 4 piles in a group, 2 by 2. So if you want to find out the ultimate load carrying capacity of this pile group, this is the plan view. If you want to have the sectional view, say we take section A, the sectional view will be like this. This is embedded into the ground. So we want to find out what is the ultimate load carrying capacity of this pile group. This ultimate load carrying capacity of the pile group based on individual shear failure means the pile is going to fail one by one. When you apply the ultimate load, the pile is going to fail one by one. Progressive failure of the pile. By dotted line, these are the failure or shear lines. So, shear lines. One by one, the pile is going to fail. So, we can show this shear line here. The pile is going to fail one by one. This is called individual shear failure. And for that case, QUG will be number of piles. Let the number of piles be n. Here n equal to 4 for this case. So number of piles multiplied by ultimate load carrying capacity of single pile. So we have seen for single pile how to find out the ultimate load, and it has to be multiplied with a group efficiency factor, eta G. Because it is not equal to number of pile times the ultimate load carrying capacity of single pile. The reason being, the piles are so close to each other, the pressure bulb, when you apply the external load, the pressure bulb is going to get developed like this. Now you see the pressure bulb are getting merged. And because of the merging of the pressure bulb, you will not have QUG equal to n times QU of single pile. You will have to multiply it with a group efficiency factor. So this group efficiency factor is very important. Group efficiency factor. Now, how to find out this group efficiency factor? Say for 2 by 2, 4 piles in a square pattern, if you want to find out the group efficiency factor, how will you find it? So there is a formula given by Converse-Leverrier formula, which can be used for a square pattern, for a rectangular pattern. The formula is known as Converse-Leverrier formula. According to this, the group efficiency factor eta G is given as 1 minus theta by 90 into m into n minus 1 plus n into m minus 1 upon mn. This is the formula, where theta is given by theta equal to tan inverse diameter of the pile upon center to center spacing. So diameter of the pile D and center to center spacing between two consecutive piles. So you can show it like this. This distance small s. Now as per codal provision, you will find that center to center distance between the pile is normally kept between 2.5 times D to 3 times D. So if you keep it 3 times the pile's diameter, then the value of theta is going to be 18.43 degrees. So codes suggest that center to center distance preferably be kept 3 times the pile's diameter, and therefore you can calculate. If you keep it 2.5 times D, you can substitute here and then calculate the value of theta. So for 3D, the value of theta is going to be 18.43 degree. So eta G is known to us, and therefore we can substitute the value of eta g, we can substitute the value of single pile, ultimate load carrying capacity, number of piles being known, and hence we can calculate the ultimate load carrying capacity of the pile groups in kilonewton. This is the simplest way. Eta g can also be found out using Feld's rule. So Feld's rule can also be used, which says that this eta g is given as 1 by 16th time of the piles interaction. So here you can see that each pile has got interaction. If I have got 4 piles, it has got interaction with this, interaction with this, interaction with this. So each pile has got 3 interactions. Again, this has got interaction. So 16 minus number of interactions multiplied by number of piles divided by 16. So you can calculate this one is going to be 13 upon 16. So eta g you can find it out. So eta g can easily be found out by using Feld's rule, or you can use converse Lebedev formula, and you can substitute in this. This is based on individual shear failure. Now the pile can act as one unit, one monolithic unit. It is not going to fail one by one. On the contrary, it will act as one monolithic unit and it will fail. What do you mean? That is called block shear failure. So what do you mean by block or group shear failure? And based on that, the QUG you will have to calculate. So same pile group, let's say if it fails under block shear, how it is going to fail? So under block shear, the failure could be under block shear, or group shear failure. So if this is the pile group, this is the plan view. Here the pile is going to act as one unit. So the failure lines or the shear lines will get developed on the periphery of this pile. Pile is not going to fail individually, rather it is going to fail in group. That means if you take the sectional view, this is the pile, the shear line will get developed on the periphery. So it will get developed here only on the periphery. So based on group shear failure or block shear failure, here the soil is going to be the part of this pile group. So this is going to fail in block shear or group shear like this. Then how will you find out the ultimate load carrying capacity of this group? QUG will be equal to the unit skin friction is going to develop on the periphery. So unit skin friction multiplied by the perimeter of the group, because it is going to develop on the perimeter, on the periphery into the length of the pile. So this is the skin friction that is going to develop on the periphery, plus at the end, because it is acting as one unit, so the unit end bearing QE multiplied by area of the group. So this is the, you are going to get two values from 1 and 2, and the lesser value, lesser of the two values should be taken, should be recommended as ultimate group capacity of the pile. So ultimate group capacity of the pile can be found out like this. If you solve one example on this, you will be able to understand the whole concept, the whole analysis and design of pile groups. So in the next slide, we will be dealing with that. Thank you very much.